All right. Hello and welcome. So, this is Ajang Aban here, and this is my segment for the foundation, for the course unit of Foundations of Artificial Intelligence, basing on the topic at hand, which is the traffic prediction module. So, we here in this assignment were given 10 modules, and you had to discuss all the 10 modules in regards to your project that you're doing. So in the project that I'm doing here right now, I'm doing the traffic prediction model to help predict traffic in certain areas and to help ease transportation and movement of people and individuals. So in the first module, which is the AI trends, history, and future, the first question that comes at hand is, what is AI? So artificial intelligence is the study and development of artifacts that are capable of displaying human-like intelligence. This whole concept of AI was first proposed by Professor Alan Turing back in 1950 when he published his paper, Computer Machinery and Intelligence. In his work, he stated that computers will one day be able to showcase human intelligence, human level intelligence, and be able to show some similarities between human thinking and computational thinking. So we're then going to go to the dimensions of AI. So artificial intelligence is divided into two segments. That's mainly thinking versus acting, and then strong AI versus the weak AI. So strong AI, this is a model. This is a model of a computer intelligence that is close to human-like thinking, whereas the weak is a module of computer intelligence where the computer performs tasks that, if were to be performed by a human being, we would say required some level of intelligence. So here, the difference between human beings and computers is that human beings are able to think, whereas computers are able to act as if they're thinking, but in reality they're not. They're just performing what is being programmed to them by the programmer. It's just lines and lines of complex code that is able to execute what's been given into it. So the early concepts of AI throughout the history, you have one of the very famous ones by the infamous Leonardo da Vinci, who created the humanoid knight back in 1495. Then you have the other one by Frank Brown, who created the Wonderful Wizard of Oz in 1900. So human versus computer intelligence, these are two distinct concepts that do not relate at all, not even close. So the development of AI throughout history aims to achieve human-like intelligence within computers, but these traits that make human beings intelligent are not there within the computers. So these traits include so many. You have traits such as problem-solving capability. You have learning from experience or environment. You have adapting to new situations. You have using knowledge effectively and making rational decisions. All of these computers are not able to express or are not able to showcase. So the difference between AI and conventional computing is, these are two distinct concepts. So artificial intelligence here, it uses heuristics and reasoning to assimilate or to act like as if it's thinking, and it learns and it adapts from its environment, and it handles uncertainty and makes inferences. Whereas conventional computing here, it follows predetermined algorithms, it processes data mechanically, and it's limited to adaptability. So a very good example of conventional computing are the generative chat GPTs that we have right now, the ChatGPT, the DeepSeek, amongst others. Whereas artificial intelligence, I don't actually have an ideal artificial intelligence model right now, based on the technology that the world is in right now. We do not have that yet, but hopefully in the future, we may or may not come across one. So what are the prerequisites of developing an AI model? So these are the steps or the components which are needed before somebody thinks or plans to develop an AI model. So one, you need to have a strong mathematical background and programming skills, especially in Python. You need to have familiarity with machine learning frameworks and libraries. 3, you need to have thorough understanding of the data life cycle. 4, you need to have access to computational resources. 5, we need to first define the problem which you want to solve precisely. So what is the problem that you want to solve, and how are you going to go about solving it, and what resources are you going to need? All that is considered. 6, you have to analyze the problem thoroughly. 7, you have to isolate and represent the task knowledge. Then last but not the least, you have to choose the problem solving technique. So whenever you're choosing the problem solving technique, you have to choose a technique or like a method that is cost efficient, that is going to give us the most sensible cost when it comes to solving the problem. So it has to be cost efficient, and it also has to be, at the same time, it has to be accurate and has to be reliable. So the module 2 of the course unit it talks about problem solving in artificial intelligence. So when deciding to develop a model, we need to clearly define the problem which we aim to solve. So this requires all the documentations as well as abiding with the presiding laws surrounding the development of AI in the environment by which we're developing it. So the problems are solved by applying heuristic approaches. So these are functions that estimate how close the state is to the goal. So for example, here for our project, we're aiming to build a model that predicts the possibility and chances of traffic in certain areas, thus giving insights on optimizing transportation by reducing the congestion, improving safety, and making travel more efficient and sustainable for individuals. So the way forward to solving a problem, we have to first choose the problem. We have to first choose the problem. We have to consider all the possible ways by which we can solve the problem and the most minimal cost possible which we can occur. And so this can be achieved by considering the different algorithms, such as the algorithms for developing this module. So we can either choose a depth first or maybe a breadth first algorithm type of solution. So the measure of algorithm efficiency is defined by the number of nodes that need to be explored, making it feasible to find a solution for complex problems. So therefore, we should consider an algorithm with the least number of nodes to solve a problem, making it cost efficient for us. So we have heuristics, which is deep dive. So these are functions which are used to solve problems, and they can be classified into different groups. So you have the first group is the admissible, and second group is the inadmissible. So the choice of an algorithm depends on several factors which you have to consider by the developer. So this can be the speed, like how fast the developer wants the algorithm to solve the problems. Second, the cost of development. Third, the accuracy and reliability of the algorithm. So admissible versus inadmissible. So admissible heuristics, they never overestimate the cost to reach the goal. It never returns value greater than actual cost, and it guarantees optimal solution. So this is the most sensible choice when you want to get the most out of your money, most out of the development. So then inadmissible heuristics, it may overestimate the cost and it's faster, but it misses optimal solution. So the third module talks about problem solving by search, the and/or graphs. So problems are usually broken down into trees, into branches to be solved. So that by breaking the problems down into trees, it makes it easier for the algorithm to manage it since it's in smaller rations. So the problem here is solved by breaking them into smaller manageable rations. This provides the solution paths. That is the AND relationship. Then the OR, it might provide the alternative, which is the OR relationship. So the use of the AND OR graphs help to solve complex problems in the traffic prediction module by formulating strategies taking into consideration the contingencies which occur, maybe such things such as congestions, accidents, social events, amongst others. The problem is then broken down into three structures. So it's broken down into the state, which are the nodes, then the OR links, which are the actions, and then the and links, which are the events. So for our case study for the traffic prediction module here, we're taking into consideration a vehicle with a known location and a known state of traffic network. So the vehicle's current location and the state of traffic is then presented by using states or nodes. So therefore, let's say the location of the vehicle is in Mayenga, and then the traffic condition is congested. But now, under the traffic condition, let's say we have 4 different conditions. Let's say we have the traffic can either be light, moderate, heavy, or can be stopped or stagnant. So the action that are performed by the driver, which is the all links, can be, let's say, turn left, turn right, continue forward, and make a U-turn. So the contingencies or the events, the unlinks, are the actions the AI does not expect but must account for it. So for example, like let's say there's a lane that is being blocked. Let's say the highway is being blocked. So there, the algorithm has to come up with an alternative to solve this problem. So let's say, for example, they can say maybe, hey, so since let's say highway 303 is blocked, maybe use highway 304. So all this is calculated by the algorithm to come up with the most reliable and accurate prediction. So this is a simple illustration of the and or graph. So here we have a simple question, like let's say the individual wants to buy a car. So he can either buy the car, like get the car, and buy using his own money, or he can just steal one. So this is a simple illustration of how the and or graph looks like and how it operates. So the module 4 talks about knowledge representation and reasoning in the AI space with regards to the model which we're doing in regards to the project and that we're really chose to do, which is the traffic prediction module. So this segment here covers the representation of data, and information, and how it's used to reason and to come up with output. So for example, here we have a diagram of the hierarchy format of data and information. So at the bottom, at the bottom we have data, then which is made sense of, or like added in this understanding added into it. So it's changed from data to information, and then it's transformed to knowledge through personal applications, values, and beliefs. The knowledge is turned into expertise. That's through enriching it through experience, training, and education. So this is the hierarchy of data and information, whereby it goes from data, transform to information, transform to knowledge, transform to expertise. So the implementation of the core concept into the AI module. The efficiency and accuracy of the module all boils down to the data information fed into the module. So this is a classic example of garbage in and garbage out. So let's what you feed into the module is what exactly they're going to get back as an output. So you have to make sure. So you would try to make sure we put in the most reliable, the most up-to-date data, so that the module gives us reliable and accurate outputs. So without the most reliable data and testing, the module might not be able to make the best out of its purpose. So for our module here, we're going to be dealing with 4 categories of knowledge and information. So this can be 1, historical data, historical traffic data. So that is to say what usually happens in an area. 2, we have the real-time and dynamic data. So what's happening right now. 3, we have the contextual and static data. So what is the environment like in that particular data? Then last but not the least, we have the temporal and event data. So this is what day it is and what's going on in the particular area. So historical traffic data, that's what usually happens. This helps the module learn from long-term patterns and trends. So here the module takes in, is fed months or maybe years of data, so that it's able to try to match or try to create a pattern